Okay, so I took a bit of a break. This past week, I wasn't really motivated to do really anything at all, computers related. So I took a bit of a spring break and I got outdoors, got some hiking in, and spent some time with friends and just enjoyed life for a little bit. Um, but yeah, I wanted to pick back up where I left off with the Carnegie Mellon computer systems, a programmer's perspective course content. One thing that came in yesterday was this book here, Compilers, Principle, Techniques, and Tools. This is the Dragon book. Oh, it's a dragonfly. That makes so much sense. I was bummed out because all the editions of this book have had dragons on the cover, like red dragon, and there's different colors. But this one, which is Pearson, India, um, it's an updated second edition of it. It was published, I think, 2023, maybe. It has like video content with it, which is really great. Sorry, 2024. And yeah, I've gotten a lot out of the Pearson's paperback for computer systems and programmers' perspectives, so I figured I'd pick this thing up. It is about, about 1,000 pages. So equivalent size to the other book that I'm reading right now. So I won't be taking this on immediately after I'm done with that. One of the things I want to do with this stream is to not be so hyper focused on a single project like I've been for the first start of the year, first quarter, basically. I've done one project after another, and what I've realized is with these longer projects that take a long time to complete, these learning projects where I'm reading a 1,400-page book along with exercises and practice problems and homework questions and lecture content and recitations and labs and like all this course material that I'm doing. It's like a whole big thing. And it is nice that I can sometimes just like narrowly focus on making progress on one thing. But I think what I want to do is allow myself a little bit of freedom, so I don't feel like too forced. Basically, I want to avoid burnout. I felt like leading into last week, I was a little bit burned out on this Carnegie Mellon course. And I think if I allow myself a little bit more diversity in things that I'm like investing time into, to take a break from like the main thing I'm doing and maybe have some secondary fun things, that'll kind of like allow me to like let that stuff sit for a little bit and come back to it renewed, instead of doing what I did this week, which is I guess I did a little bit of like mental refresh for me, but for the most part, I wasted a lot of time this week, this past 7 days. Yeah, I played a lot of video games. Played a bunch of Megabonk and Terraria, and watched a lot of YouTube and movies and stuff like that. So I want to kind of avoid that, that kind of burnout I felt it with the Linux programming interface when I read that book. I would have 3 great weeks of productivity and then 1 week of really like shit progress where I was just forcing my way through it. And I was able to finish that book, but it wasn't very satisfying when I finished it. So I go on these sprints where I finish like a 200-page book easily in a week, but like these like 1,400-page books that are not just the reading, it's also reading plus problems, like applying your knowledge. Like that whole thing like just takes up a lot of time and a lot of effort and a lot of like mental capacity. And trying to like get that done within like a month or 2 months, like sometimes it just takes longer to get through all that stuff. And I think that leads to like kind of me burning out because I don't have that reward. You know, when I pick up like a 250 page book and I read it in a week in the evenings and I learn a lot, I feel really gratified about the progress that I've made. It's kind of like it builds upon itself. Whereas this thing, I don't feel like gratified. I am making progress, I am learning things, but like it's not high dopamine reward. Yeah. Which I hate to say it, but like the work that I do in studying is competing against a lot of high dopamine systems. One thing I want to do is I want to start doing Brilliant. Might actually log into that right now. Why is this not resolving? Oh, I disconnected the network on this machine. Let me go. Felt like I couldn't visualize it all in my head. I needed to have some type of graphing calculator or Desmos or something loaded up. So I might revisit this calculus stuff when I get when I start doing stuff on stream here. What else? I did a thing on algorithm. This thing I got very little value out of doing algorithmic thinking. But then I started on the computer science fundamentals and I started leafing through some of the content here. And some of it's like stuff that I think it would be useful for me to revisit. Yeah, some of this graph stuff would be great. Eulerian paths, I'm not even familiar with what that is, so I would definitely learn something there. I mean, obviously, I've done interview prep before. I've gone through discrete mathematics before, discrete systems, so I'm familiar with these data structures and the mathematics behind them. But it just helps to come back and revisit them. It doesn't take a lot of time, and it's highly rewarding. So that might be something I do during stream, just to kind of like take a break from the main stuff that I'm working on. So yeah, that's kind of like where my head is at right now. Is I want to have the stream be something that I can do a diversity of different topics and still feel like I have like a few areas that I'm like making a lot of progress on large projects, but not feel too tied down to those things, if that makes sense. Let me pull out my chat here. So yeah, That's what I'm thinking I'm doing with the stream moving forward. And that'll get me onto the stream earlier in the day, because I feel like what happens. I wake up pretty early. I wake up around like 5:30 to 6 in the morning. I get into the gym by 6:30, and then exercise to 7:30, and then I get home around 8 usually. Have to shower and like kind of get ready for the day, eat breakfast. But I feel like by 8:30 I should be on stream. But inevitably what happens is I check my phone, I start chatting with people, which is fine. It's nice to chat with people, but chatting with people leads to me going on YouTube and me going on social media and like wasting just a lot of time. And then my entire morning will be wasted. And then I kind of feel down because basically I didn't want to get started on this like a tack lab or something, whatever the next step I have in front of me is. I just didn't want to take that next step, which leads to me like wasting my entire morning, which leads to me feeling shitty about not getting on earlier to study earlier, and then I just say fuck it and I just go play video games for the rest of the day or whatever. So that's been like the failure mode, I guess you would say I've been in for about a week now. So yeah, what I want the stream to be is a more open-ended. I can just sit down at my desk, start doing some brilliant problems, start playing with things that kind of like come up that I think about like in the shower or whatever, and just start doing stuff that I enjoy. Like start my day with enjoyment and then move into more serious work. I'm going to try to do that, because the hardest part for me is just getting the day started at this desk, sitting down at this desk and cracking the book open and starting, clicking start on the stream and starting. So I feel like getting in the habit of getting the thing started earlier in the day with stuff that's easier will allow me to just make more progress in general in my learning objectives. So that's where I'm at. I'm really excited for this compiler's book. I will not be cracking this open until later this year. It's been one that I've been wanting to read for ages. One of my mentors when I was just graduated college was reading an earlier edition of this book, and he was writing his own little toy language for microcontrollers and highly recommended it to me. And so naturally, it's been something on my list to read for ages now. And there's a lot. I leaf through the index and through some of the chapters, and there's just a lot here. There's a lot here. So I want to be fully ready for this before I just jump into it, because some of it is like challenging for sure. And I guess another thing I want to start doing is like having a project in mind for every book that I read. I have another compiler's book here, Modern Compiler Implementation in ML. So if I read these two compiler books, it's like what, like probably like 1,800 pages on compiler techniques. If I do that, like what is the end result of that lengthy effort invested in learning about compilers? What is the end result that I want? I want to have a better understanding of the tools that I use, programming languages, and the trade-offs and decisions that the language designers have made. I don't really want to create my own languages, but I want to be able to potentially contribute to a language, a programming language like Zig or something that's less mature, or even just contributing to optimization of a language. But fundamentally, I just want to have a better understanding of the inner workings of compilers and how different languages translate language constructs into executable machine code. So that has a lot, and also I want to get better at just parsing languages and understanding the performance characteristics of parsers, which hopefully I get some insight to that reading these books. So I think having like clear objectives going into it. So those two books I'm not going to tackle until like the end of the year. But having more clear objectives, like the Linux programming interface book that I read, I had a very deep desire to read that book for a long time because it's just a wealth of Linux information, and I'm so happy that I did it. I've learned a lot in reading that book. The C programming language, that was a book that the KNRC book was a book that I had on my list for a while. I had read probably about a quarter of it. And so getting those two books read was more a satiating, long-held desire to complete those books. And so I was naturally motivated to do that. Whereas this Computer Systems, a Programmer's Perspective book, it's, I guess, in some ways satiating a need in that I'm getting better at reading and writing AMD64 assembly and kind of translating between C and assembly and getting a better fundamental understanding for how the GNU C compiler and Clang work, how they translate C language constructs into assembly code. But I didn't have a very clear objective in like reading this book other than just like wanting to have that skill set. So I think that the kind of capstone project for this book will be implementing my own shell, because that is a lab that they have as part of the coursework. So I do the lab and then kind of gain a feel for like how I'd want to expand the shell implementation. And so that involves like designing your own language, your own shell language, forking or cloning processes, setting up pipes, connecting the file descriptors to the spawn or clone processes. Doing all that type of shell type stuff. I think that will be the capstone project for this, to just get really familiar with how a shell implements its functionality, the core functionality. Obviously, I don't want to go into super detail. The capstone project for the Linux programming interface was that epoll file server, which I'm probably only about 90% done. Like, I got the initial idea out of my head, but I haven't finished it to where I don't have benchmarks written. I don't have the HTTP logic implemented. There's like still work to be done there. I want to take that to a place where it's like kind of like a nice little artifact that I can demonstrate. Hey, I know how to do event-based IO with epoll. At the very least, I can demonstrate that, and I also understand how basic concurrency principles work with pthreads and pthread mutexes, and coordinated between multiple threads that are doing an epoll wait on the same set of file descriptors, or the same epoll file descriptor, I should say. I guess that is kind of where my head's at. So I have a D&D tonight, so I'm going to break probably around 5. So it gives me a couple hours here. I just want to get on, just kind of break back into this habit of getting on. One thing I do want to do before I get started, because I want to work on this lab, is I actually want to pull up my calendar. So I'm going to do that. I have to blur this thing because I don't think I have my password. So give me 1 second here. And then let me see if I get access to my calendar here, because I do want to set up a calendar to kind of like keep me honest. With a schedule. That's what I need. I need a schedule that I keep myself honest to. So, what am I doing here? Okay, here, and that's blurred. Okay, so that doesn't work. Give me 1 second. Because I need to switch over here and grab my credentials. Boom, 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 boom. There we go. Nope, that is not right. There we go. Okay, looks right to me. Switch back over here. And boo, 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 boo. Where is my thing? Okay, I'm back. Welcome to Proton Calendar, where you can take control of your time and your data. Start using Proton Calendar. So, I think what I'll do is I'll set up my schedule here. So, we're going to start here. So, every day from 6:30. Oops. Can you do 6:30 maybe? There we go. 6:30 to 7:30 will be gym. Should I do the whole thing here? Yeah, why not? Yeah, we'll just do that. It does repeat. Custom Monday, Tuesday, Thursday, Friday, every 1 week. Doesn't end. Done. Save. Okay. Then we'll do the same thing. I drive to gym. Monday, Tuesday, Thursday, Friday. Done. Save. This will be a drive home. Monday, Tuesday, Thursday, Friday. Save. And then What else? So that means what I want to do, where did I start? I started today at 25 minutes ago, which is around 2, right? Yeah. So I'm going to say here, we'll do a one-time thing here, stream until, I said 5. Welcome back, stream. Bam. And I think what I'll do is I'll put these under a different color. We'll just make them like purple, sure. Save, all events, update. And then we'll do this one on gym. Do the same thing, purple it. Okay. I'm gonna give myself an hour here after I get home for shower and breakfast. Purple it. We're going to repeat custom Thursday, Friday, Monday, Tuesday, 1 week. Save. Okay. And then this is going to be our stream from 9 to noon. That'll be morning stream. Sorry, custom. Oops. Hey, there we go. Custom. Done. Save. And then we'll do a purple here, which is lunch. And then we're going to do 30 minutes of cardio. Purple. Custom. Monday, Tuesday, Thursday, Friday. Save. Cardio. Save. Alright. That means that at 1:30 I need to be back on, and when I stream to 5, we'll call this the afternoon stream. And then this can repeat. I kind of feel like, yeah, discard changes. Yes, discard. This maybe we do every day. Custom every day. Same thing with this one. Every day. Save. Okay. Actually, you know what I'll do here is I'll just delete this thing, all events, call this one lunch/cardio, and then do that to 1:30. Save all events. There we go. And then this will be afternoon stream every day. And then dinner purple. Repeats every day. And then this will just be wind down time. Wind down time. And then go the fuck to sleep. So this will be a purple. It's a purple. And it's gonna go to 5:30 a.m. the next day. So 7:30, say I get to bed, actually get to sleep by 8. That means that I'd be fully rested by 4, which usually doesn't happen. But we're gonna try it anyways, and then we're gonna wake up at 5. I'll set my alarm for that. Actually, you know what? Check my calendar on this thing. Oop. Okay, so I can't. Let's push this down. $8 p.m. Let's say 8:30 I get to sleep. That means 4:30 would be when I wake up in the morning. So I think 5 would still be fine here. Which is 9 hours with a 1 hour buffer for going to sleep and waking up. So that'd be my sleep schedule. Every day. And then we'll just edit this to be to 8. And then my D&D is 6:30. So that'll just be part of my wind down time. But let's go ahead and add it. So it's 6:30 to 8 here. Oops. So that means that this needs to go and say, hey, every day but Wednesday. Cancel. Custom. There we go. Done. Save. All events, update, and then here we'll have, move it down here. Repeats every week on Wednesday. This thing, can I click and extend it? No, it doesn't work that way. To go here and say 6. Okay. I don't have time for dinner here though. That's where I went wrong. Okay. So this needs to go 5. We'll add a little dinner here. Okay, that's a good blocking of my week. And then I'm gonna go to this week. So you can see these holes on Wednesday, Saturday, and Sunday. So Sunday I need to find time for, well, I want to be a little bit more flexible on my weekends, at least in the morning. Trying to think. Why don't we just say fuck it and like get on early? I do need to get breakfast though. So 6 to 8. This will be custom these 3 days. Then we'll have just breakfast on these 3 days. Okay. Does repeat. Custom. Sunday, Wednesday, Saturday. Done. Save. And then this can then extend to custom every day. Huh. It moved it. Can we do 26? From 9 to 12 every day. Save. All events update. Does that fix it? There it goes. Okay. So this is my life, roughly. Sunday, I have some things that I need to do. Well, I guess I have an accountability pod meeting, but it fluctuates between Friday, Saturday, Sunday, and Monday. So those 4 days I'll just have to fit it in and cut a stream short. But other than that, this is my schedule, my stream schedule moving forward. I'm going to commit to doing this. So I need some type of reminder to keep me honest here. I need to set my alarm for my sleep schedule. So the first alarm I need to set is a go to bed alarm. Getting my shit together here. Alright, so can I edit this maybe? Every day. Gonna be label is go to bed, which will start at 8 p.m. So it'll be 8 p.m. And then I'm gonna say wake up every day at 5 a.m. 5 a.m. Okay. Okay, that is my life programmed out. I do this usually once a quarter where I just block out all my time. And it's getting close to the end of the quarter, so it seems like a good time to do it again. And I figured doing it on the calendar for my stream account would be yeah, let's allow notifications. Would be appropriate if I'm going to be sharing this on stream. So 5 a.m. to 8, say 8:30, 9, 10, 11, 12, 5. Okay, that should be fine. Okay. Let's see if I can stick to this. Let me go ahead and install the Proton app here on my phone. Oh, I have Proton Mail already. I need to have the Proton Calendar app. I could probably just use like Notion and share the calendar. Which makes me think like do these things have a, yeah, these all have like notifications. Okay, I'll install it and see how it works. Okay. Alright, we'll let that run. Might be nice to set up a calendar app here. So if I say install web app, I can say calendar. Calendar. Yeah, I'll just say calendar. And we'll just do that as the URL. Wait a minute, that's not a URL. Of course it is. Maybe it's trying to do a favicon query. Maybe that's what messed it up. Let's go here. Proton calendar. Yeah, there we go. Grab that guy, and then it wants a PNG, right? PNG icon URL. Copy direct URL. There we go. Okay. Now when I launch calendar, bam. Then close out this. We have that on the back burner here, so I get notifications, hopefully. All right. Okay. That's now saved on my phone, so I get notifications on my phone as well. All right. Cool, cool, cool. So what do we want to do? What do we want to do? Well, the obvious thing is to start working or continue working on the attack lab here. That'd be an obvious thing to do. I don't know. It took me so long just to get this thing up and running with all, and reverse engineer its like connections to these servers and spoofing out the host name and creating this little Go server for it to connect to. So All right, we're on page 5. Let's just focus in on the PDF here. So we kind of left off about here. So I'll continue reading there. How many pages is this? So it's about 14 pages. So we got 9 pages left to read. Okay. For the first 3 phases, your exploit strings will attack C target. This program is set up in a way that the stack positions will be consistent from one run to the next, and so that the data on the stack can be treated as executable code. These features make the program vulnerable to attacks where the exploit strings contain the byte encodings of executable code. Level 1. For phase 1, you will not inject new code. Instead, your exploit will redirect the program to execute an existing procedure. Function getBuff is called with within C target by the function test, having the following code. Function getBuff is called within C target by the function test. Okay, so it says test getBuff, no exploit getBuff returned 0x. When getBuff executes its return statement, line 5 of getBuff, the program ordinarily resumes execution within the function test at line 5 of this function. When it changes behavior within the file C target, there's code for a function touch1 having the following C representation. This is V level 1, part of the validation protocol. Touch1, you've called touch1, validate 1, exit 0. Your task is to get C target to execute the code for touch1 when getBuff executes its return statement. So we have to overwrite on the stack the return address from tests line 5 to touch1. Your task is to get C target to execute the code for touch1 when getBuff executes its return statement rather than returning to test. Note the exploit string may also corrupt parts of the stack not directly related to the stage, but this will not cause a problem since touch1 causes the program to exit directly. So that should be pretty straightforward. Let's read the advice. All information you need to devise your exploit string for this level can be determined by examining the disassembled version of C target using object D to get the assembled version. The idea is to position a byte representation of the starting address for touch1. So that write instruction at the end of the code for getBuff will transfer control to touch1. Be careful about byte ordering. You might want to use GDB to step the program through the last few instructions of getBuff to make sure it's doing the right thing. The placement of buff within the stack frame for getBuff depends on the value of compile time constant buffer size, as well as allocation strategies by GCC. You'll need to examine and disassemble code to determine its positions. Okay. Seems reasonable. I'm going to send this to 2, and then you can send this to 3. Okay. And then over here, so we've got our C target. Now I was running this thing with GDB, I think. It does have an in file similar to the previous lab. This is the third lab that we did. We had a bomb lab, the bit manipulation lab, and now this attack lab. Okay, so what I'm going to do is the relevant information here, we'll say level 1, C target level 1. We'll do it like this maybe. I'll do it like this. And here, function. Let's go back over here. So test calls get buff, have get buff return to touch one. That's basically the whole thing right there, right? So let's run C target under GDB. So GDB C target, and can I say info symbols? Help info. Let's see. Symbol, describe what symbol is that location adder. How to, let's close this out. How to dump symbol table in GDB. Info functions, info variables. We'll say info functions. Please collect, yes, info functions. All defined functions. Interesting. And then a bunch of stuff here that has addresses for it. Is buff C, so this is our get buff. Does not have an address. That's fun. Does get buff exist anywhere down here? No. Let's go back over here. I guess I don't really need it. I can just refer to it as get buff, right? So I can say breakpoint at get buff, restart, disassemble, get buff. So this is where it calls into gets with a capital G. Oh, it wasn't get buff, it was called test, breakpoint at test. And if I do a backtrace here, you can see I'm in test. So I'm actually in the right location here. I need to print out the stack. BT full. Info frame. Yeah, I'm thinking this, but with stack pointer. If I say X, this asks here, if I say extract 32 64-bit as assembly from RSP. So this is, wow, okay. Oh, that's because that's above. You want to go negative. RSP minus 0x40, yeah. Would be 4, yeah, it's 32 64 bits, that's 8 times 32. G is 64 bits, right? Yeah, 1, 2, 3, 4, 5, 6, 7, 8, yeah. Eight would be 1, 2, 3, 4, 5, 6, 7. That'd be 8 times 8. So I print out $RSP. This is going to be CAO, which is this one. Like I said, 1, 2, 3, 4, 5, 6, 7, 8. And I want to include where the CAIO is pointed at. If I just do this, it's all zeros. Wait a minute, it doesn't seem right. DCAO. Why does it say it's all zeros? Oh, I did the wrong one. I should have done this one. Okay, so that's this one, 7, 6 here. Can I just turn this to be then? Instead of 32, we'll say 8. 9. So this would be 3, 8 here. Yeah. Okay. How do I print the address for each of these? Not 2 per line. Oh, it's a dump stack. Dump stack. Can I just run that? No. There's no dump. Oh, that's if you define it here. Okay. There we go. Nope, didn't work. Let's do 16. So this is the address of test plus 14. So this is a return address here. So basically the return address is on the stack, which is what we would expect entering into here. So if I disassemble this thing, this gets call is gonna, so we subtracted 28 here, which would be how many values? 1, 2, 3, 4, 5 values. So if we do a single step here, and then we do our disassemble, or sorry, we do our stack pointer dump, which I think I was doing like, yeah, that's fine. Oh, did we not do that? Disassemble? Yeah, we added. Seven, 8 now. Oh, but we're going up from stack pointer. And that's going down. And we're going up in memory. Okay, so that makes sense. So you have 1, 2, 3, 4, 5. It's a sixth element. Sixth 8-byte element. And we have to consider our encoding, our Indianness. So if we go here, I'm just going to dump all this here. So what is this value that was on the stack here? This 5 something or other. Was that on there before? Before I did my single step, when I printed out the stack, it was on there. And we're going lower in address as we go up here. So you had a bunch of zeros not on the stack. We have this thing, and then we have the return address. So what was this thing? If we do our BT, this as test, it might have just been leftover stack stuff. What does the call quad word instruction do? I think it just does a push of the return of the next instruction onto the stack, the return address, and that does a jump to that location. Pretty sure that's all it does. So that means that our return address was top of the stack. And if we go up here, our RSP was CA0, DCA0, which before we did our single step, DCA0, this is going up, would have been here. So it's going up in addresses. So this is just garbage data, I think. Yeah, that was just garbage data. And it happens to still be there. So if we go here, and if we look at our backtrace again, you can see launch was at that location. Yep. And this dump that I did here, where did I copy that from? This one here? No. This one here. So that was before or after? It was after our single step. and it's from RSP minus 38. If a printout RSP is C78, which is here, which is 7078, 1, 2, 3, 4, 5, 6. A 10 would be A, right? So it'd be 7A, B, C, D, E, F. Then we got 8, 9. These should be 8 values. 1, 2, 3, 4, 5, yes, 8, 8, 9. And then A here. So is it 802 8F? This would be 90 to 9F. And then A0 here. All the way up 1, 2, 3, 4, 5, 6, 7, 8. And then if we get our address, which would be just print out touch 1, which is this address here. So we have 8 bytes. The low order would be C0, 1, 7. And then 4, 0. And then we can leave these. These are fine. Okay. Oops. So we have what, 32, 40 bytes that we have to write. And then we write these 3 bytes. So if we go into our I'm going to exit here. quit. Yes. This will be level 1. C target. C level 1. TXT. Yeah. And we have this program here, which is hex to raw. Okay. C. We'll go back here. Set tech OBI. And we'll say, hey, bim that up here. So when we have 1, 2, 3, 4, 5, 6, 7, 8. Oops. 2. Okay. 1, 2, 3, 4. And then here we'd have the bytes in order from least significant to most significant, which would be C0, 17, 40. Never run the hex to raw on that file. Okay, so these have to be just spaced out. Bim. Okay, let's go here. One, 2, 3, 4. Wait a minute. These are nibbles. So that's 8. No, 1, 2, 3, 4, 5, 6, 7, 8. 8, 16. What the hell? Where does this 0A come from? It says 32 bytes, which would be 16 would be 1 0, that would be 2 0, and then this is too many. Oh, and there's a 0A at the end because it's a yeah. It's still too many, and you still have the new line at the end. So it seems to only do the trailing new line for some reason. Okay, but we got 1, 2, 3, 4, 5, 6, 7, 8. Yeah, it's the right amount. But why does it say 2, 0? Shouldn't it be 1, 0? Doesn't make sense to me that it says 2, 0. 1, 2, 3, 4, 5, 6, 7, 8. So that's 8 bytes. And then that means this whole thing is 16. So shouldn't this be a 1, 0? Are those nibble positions and not byte positions? Well, that would be 1, 0 there. Maybe take away the ASCII. No. This should be a 2-byte sequence. Yeah. That should be a 3-byte sequence. 4, 5, 6, 7, 8-byte sequence. Why is it when it gets to 8? Oh, because it's an octal. Even though I said hexadecimal here, it prints out hex here, but octal here. Man, OD, can I... address radix. So let's say dash AA X. There you go. Okay, so that's just my AX, like that. There we go. So bring this guy back. Bring that one back too. Alright. And I'll add a 0, 0 here just for good measure. Yeah, okay. Yep. So that would be 1, 2, 3, 4, 5, 6, 7, 8. Let's go back to man OD. Skip bytes. Null. No. A V. Want a V. Did that not work? V? There we go. Okay. Yeah, that looks correct to me. We want to get rid of that new line though. So we'll just say here on Linux with them, how do you oh no, sorry. Oops, on Linux, How do you drop the last character from a file when processing? Okay, we just truncate it. Can I do cat c? Oops. Actually, you know what? Hex to raw help. Okay. So maybe I can do a dash here. Is that too much to hope for? And cat out our C level 1 into that? No. Okay. But I can do one of these guys here. So let's go back over to here. Oops. This one here. Cat out C level 1.txt. Truncate. Wait a minute, it just gave me the last new line. Not what I wanted. Maybe if I do the sed. Let's try that. Let's do, yeah, this. Nope. In fact, that had no effect at all. It looks like it worked. Kind of. So if I just cat out C level 1. Oh, I guess the truncate worked? Huh? Okay. So let's try, why is the new line still coming out then? It's putting it there. Okay, that's good. That means it's C level here. Abort, foreground. We're just gonna put a space here and then remove it. Yes. C level 1. Okay, so that's the right thing. And then we'll just do a truncate. So we say, hey, hex to raw there. We'll do the sed. Yep, looks correct to me. Alright, looks correct. This guy. Okay. So now I can say, hey, C target, help. There's like an input file here, right? I see level bin. Yep. And shouldn't that exit? I thought it called exit after touch 1. GDB args. Breakpoint on touch 1. And we'll say continue. Sorry, return R. BT here. We corrupted that address. That's fine. Should we have? I don't think we should have. Disassemble. I thought we exited after this. Didn't the instructions say that we exited on touch 1? But I'm in touch 1 here. There's an exit here. Oh, I get stuck on this validate thing. Oh, because of this thing up here. Isn't that funny? It's doing a little HTTP request up here. I guess I need to respond to that. Let's put a breakpoint on validate and restart, and yes, continue, disassemble. All right. It calls puts, check fail. This first puts here, let's see what's there. So we print out our char star of that. Sorry. Mismatched validation levels. That's not what we got. We got, what did we get? Valid solution with level for level 1 with target C target. So you don't go down this path. Because that would imply that mismatched validation levels. What is this is checker thing? What is this? Char star of this. Invalid cast. Okay. This one. Another invalid. Oh no, that's my code. Where does this thing jump here to? I guess it's single step through it. Dis s. So it's going to print out this. And then I got this. Where is it? Up here. Valid solution for level 1 with target, see target. If I go all the way down here, notify server is the problem. So if we put a breakpoint on notify server, continue, this asks that. Let's look at the calls. So we have here a printf call. Quit, please. Print char star. Don't care. Exit, that's error handling. Where's the next call? Here it is, driver post, even though it's a GET request. Submit R. I'm just gonna have it respond with like 200 OK or whatever. So let's go ahead and do that. I'm going to rebuild this thing. Do that. So vim server.go. Don't care about that. Okay. I think this will hit a EOF. I think. Will it? No, probably won't. But we'll try it. So con.write. Sorry. Yeah, right. Slice a byte of this string, which is 200. Okay. See, they're not saying HP11, so I'm not going to say it either. So if we do that, we'll kill this, rerun it, continue. never got there, which is what I expected. Let's go and restart. Or sorry, kill, restart. Yes, we'll hit our breakpoint. Foreground here, actually, sorry. Vim server.go. I need to do this in a Go routine. I think it might tear itself down if I do that first. Let's try that. Why not? Nope. So what I need to do is say a go func here. We're not going to panic error. We're just going to say IO copy with a bunch of underscores. We could actually do it like this. So we defer our connection close. We go up our IO copy, which will tear it down as soon as the defer happens. We do our write. We print OK, and we close up shop. Let's go ahead and build that. That's why I love Go. You can just easily express things like this. It's going to rerun it. Restart. Error, client unable to read status message from result server. But I said 200K. Well, let's do the full thing then. It read 0 bytes. No error, no data read. That seems weird to me. Why does it do 2? Oh, the initial connection. Wait a minute, what did I do with my right? There it is. Okay, so read, error handling, output everything. This needs to go over here. Write, error handling, print everything out. Or say N, don't need that. Oh, sorry, my bad. Maybe it's because my buffer needs to have a size instead of just a capacity. Bet you that's what it is. Oops, sorry, I need to delete this guy too. So EOF, there we go. Handle con 30. Here. If error is not equal to nil, or we say if error is equal to io.eof, then we just return. No, we can't really return. unless n is also equal to actually, you know what, in panic error I'm just gonna handle EOF. It's not equal to nil and error is not equal to io.eof. I'll solve that problem. Okay, so we do our read and write, so that's where we can skip when we read 0. So if n is equal to 0, then we're just going to return. We don't have to say write down anymore. Go. So here we go. So read 0, then we do another read there, and then we write out 10. Oh, they do HP 1.0. Okay. So let's go ahead and write out the whole thing then, which is 1.0 200 OK. HTTP 1.0, so that they do their get path HTTP 1.0 host, and then we say, hey, HTTP 1.0 200 OK. Let's go ahead and try that. So it needs some type of status message. Unable to read status message from result server. Okay. Let's go ahead and run this under GDB. And if we look at our breakpoints, was it touch 1? Validate. Notify server. And then there was like a post something or other, right? Driver post. So this guy got all the information. Make this a little bit larger. Let me just scroll back here. Nope. Okay. What do we got going on here? Submit R. Okay. Do I have like a history here that I can go back? No. Great. Yeah, return our disassembler again. We want to go past connect, past URL encoding. This is doing some writing and some reading. And then more reading. So I guess the reading here, we can maybe if we can get down to here, breakpoint here, continue. Okay, so we see that is, if I do like info variables, there's a lot of variables in this program. In GDB, how do I print? Okay, it's not working. We're after URL encoding. Here's where we do our write. I'm guessing this here. It's going to be something that we can hit. The fuck happened there? So we were at 70F and I hit next and it went somewhere else. 70F I hit next to go over this call, and it went all the way down to there, which is, so that means that the test and the jump were evaluated, and it went down to 96. Oh, we can still print out REX, see what it is. 17. Which I think is good because, where are we at again? 7AF, I think I said. 70F. If we didn't, we would have called close. There's error handling here. So we're good. We're going to do a scanf on this location. Okay, let's get down there. Let's just go all the way to here then. Breakpoint at that location, continue this S. So you want to say, hey, what's RDI, what's RSI? Well, this is going to be our format string here. So we can print that out. Print a char star here, format string. Oops, sorry, not the dollar. So it has to be in this format, SD, and then that. So a string, a digit, and some alphanumerical characters. So this is going to be call scanf, which will be a next for me. So we'll get through that. Yep. I hate having to reverse engineer their fucking grading system just to get this thing done. Okay. This will be okay, and then we say, hey, S, which is foo 12b. And then let's go ahead and do one, two, three, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Yeah. It says failed. So they're doing some type of testing on this string, which I really don't care about reverse engineering. Which is 4, 5, 6, 7, 8, still 8, yeah. Submit R. Can we do the TUI mode? Alright, this is fucked now. Down here we do some URL encoding, and we have our write here, our read here. So here we go. RP entry, user buff. So it's probably going to be this place on the stack, this user buff. Okay, what about this other guy here? The entry. No. So that just read that it was okay. Okay. Okay, here we go. Let's do a print on the char star of 40, 0x40 plus dollar, or just say RDI. It's already an RDR. Huh. Can I say extract string dollar $RDR? Can I say extract 2 strings from dollar $RDR? And that just happens to be the encoded stuff. So it got this thing, and then it's calling the scanf with what what is this thing, ESI? If we extract string from there, extract string from there. Okay, so this is for the status code. Okay, so we got our HTTP 200. Okay, so we don't need to put all that shit that we're putting in there. It's HTTP 11, that all matches 200, and then okay. So that should match, right? Okay, and I'm gonna say next on that, jump, print out $EX3. So yeah, because there's 3 things. D minus EX, A, B, C, D. So it'd be A. Okay, now we're back up here. Oh, because I'm already in there. Okay. That's a scanf, print out 3. Okay, so our RSI now has this in it. We read our line, which has content type text plain. If we go back over to here, okay. Okay, so now we're down to this string here. Yep. So I was reading little bits of the message, new line delimited. Now it has the whole message. It's saying I'm going to copy that. Alright, I'm tired of this. What time is it? Hey, how's it going, Nano? Sorry I missed your message. Yeah, XA664 assembly. Trying to debug this lab. And getting frustrated by it. I got about 30 minutes left. So I don't want to waste too much time because it's all debugging their stupid validation logic. And I just don't want to spend a lot of time doing that. So I'm not going to burn out on doing this right now. I'm going to switch gears a little bit and just do some easy peasy brilliant stuff for 30 minutes. And then I'll call it a day. Alright, binary search. So when you have a sorted array, it's very easy to just, search the array. So I think it's log n time by just going halfway into the array, checking if the value that you're looking for is at that location, if it's less than or greater than, and then considering recursing down, doing a half of the other side, and just continuing until you find it. Sorry, I wasn't really paying attention here. So searching for owner of one of the 300 million cell phones in the United States is a much bigger problem than searching the contact list of a particular phone. This would be a O of 1 hash table lookup. I don't know why you would use binary search for this. If the phone company wants to search 300 million cell phone numbers by scanning all the numbers one by one, how many numbers would it need to check on average to find a particular phone number? Will be on average about half of 300 million is 150 million. A million and a billion. It would be a monumental undertaking for the phone company to scan through every phone number. Every time a customer's phone received a call, fortunately, the sorted array makes it vastly better algorithm than possible. For searching for a value 801 in a sorted 200 element array A, we find that A0 is equal to 26 and A1 is equal to 977. We can just stop. All 198 remaining elements must be greater than or equal to the value we just observed. So they're not 801. It would be lucky to bail out after checking only 2 array elements. Where do you think we should check in the array that's less reliant on luck? Middle of the array. Looking at the middle of the sorted array splits the array into 2 equally sized parts. Only one of these parts can contain a number you're looking for, so you can eliminate the other part, repeatedly splitting the array into 2 parts in this essence of binary search algorithm. Think of a search problem as a guessing game. The goal is to guess the array index where the specific number is located. If few guesses as possible, when starting with an array of length 15, we know the target index is no smaller than 0 and no greater than 14. So the guessing interval is 0 to 14. So we'll work through the binary search algorithm considering this example. There's the array index in the middle position of this sorted array. So 0 to 14, that'd be 15 different elements. So 7 or 8, could be 8. Oh, 7. Number in the middle of the guessing interval 0 to 14 is 7. Yeah. If there was a 14th element, then it could be 7 or 8. But I guess there is no 14th element. The array contains value 19 at index 7. Just checking A7, we know that all 7 elements to the left are less than or equal to 19. All 7, yeah, okay. Starting with the guessing interval 0 to 14, which, see, watch. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7, yeah. 7 is the middle. $19. It should be 8 to 14. Maybe guessing early 14. 11. We've now completed a cycle of the binary search algorithm. Taking a step back, we can see the overall strategy of binary search. Pick an array index in the middle of the guessing interval. If your number, yeah, okay, I understand the algorithm. The next few puzzles will build on the pieces of general binary search algorithm rather than looking at a specific example. As a first step, we'll sort the guessing interval into 2 variables, low and high. You're looking for a number in an array with a known length. Your guessing interval is a little high. Where should you look to perform the next step of the binary search? Well, you're going to take high minus low divided by 2 plus low. square root of high times low? I don't know if you need to involve square roots in this. The last choice is too low. Choose low plus 1, otherwise choose high. No, the average of low and high. Yeah, that would work too. I said high minus low divided by 2 plus low. But I guess you can just add them together and divide by 2, yeah. Average of low and high is the right way to find the middle of the interval. If there's an even number of elements of the guessing interval, the average would be the whole number. This number can be either rounded up or down. The algorithm works equally well. Consider the situation. You're looking at a location for the number 20 in a sorted array of unknown length. You're guessing the interval is low to high. You've already figured out an average of low to high and stored in a variable mid. A mid contains -2. What should your next, what am I looking for again? 20. It should be mid plus 1 to high. Taking what you learn, create an algorithm for performing one step of binary search. For the purpose of this puzzle, assume taking the average of the two numbers will round the result if necessary, so mid will always be a whole number. Just saying like integer division. If a mid is equal to target, then we're done. Say, hey, found target. If a mid is greater than target, then we want to go from low to mid minus 1. Oh, you can just do the sets here. Okay. So if a mid is greater than the target, then we want to go from mid, so low to mid minus 1. So set high to mid minus 1. And then this would be this one here. Oh. So a mid is greater than target. So you have a target of say like 500 and this is greater. There's a target and a target's to our left. We want to set our high to mid minus 1. Else if a mid is less than our target, then our value is to the right. Set our low to mid plus 1. Else we have to update the mid as well. Do you do this up here? We do it up here, I guess. Yeah, that's what they're looking for. I assume they already did that. Last step is to put the single step process inside a loop. Most of the algorithm is in place, which while instruction is the right one to make the algorithm work. Okay, so we get our array while low is less than or equal to high. Oh, you gotta do this stupid shit here. Okay. Binary search is incredibly efficient. This gets more dramatic as you need to search a larger and larger collection of information. Same number of comparisons. Yeah, blah, blah, blah. Okay, great. Alright. Compare and swap. That's probably not the CAS compare and swap operation of CPUs and atomics. It's probably just literally doing a comparison and swapping. Alright. I'm going to go ahead and log off here. I got to go to the grocery store and do some grocery shopping for dinner because I'm starving. 4:45. Oops. That's weird that this calendar doesn't do 15-minute intervals. This is 30. We'll do 6. Okay. Alright. I'm going to go grocery shopping, eat dinner, take out garbage, hang out with some friends, get to bed. I'll be on tomorrow after the gym at 9 a.m. sharp. I'm going to make sure that I log on tomorrow morning. Cool. All right. Later.